morning, students. How are you all doing today? I hope that you are all doing good and feeling all right. If you are feeling all right, you may send us a heart emoji in the comment section below. If not, you may send us a like emoji and let us talk about it later. Always remember to follow the IATF safety and health protocols for us to be free from COVID-19 virus. For today's video lesson, we are going to discuss all about permutations. But before we proceed to the discussion proper, let us have a brief recall on the fundamental counting rules.
Let us try example number 1. A close friend invited Anna to her birthday party. Anna has 4 new blouses, stripes with ruffles, long sleeves, and sleeveless. And she has also 3 skirts, red, pink, and black in her closet reserved for such occasions. Assuming that any skirt can be paired with any blouse, in how many ways can Anna select her outfit? Solve the problem using tree diagram and fundamental counting rule. These are the available blouses of Anna: stripes with ruffles, long sleeve, and sleeveless. These are also the available skirts of Anna: red, pink, and black. Anna can pair her striped blouse with her red skirt. She can also pair it with her pink skirt, and she can also pair it with her black skirt. So for her striped blouse and 3 available skirts, she can wear this in 3 ways, or she has 3 pairs. For her blouse with ruffles, she can also pair it with her red skirt, pink skirt, and the black skirt. The blouse with ruffles has also 3 pairs. Her blouse that is long sleeve can also be paired with her red skirt, with her pink skirt, and her black skirt. So there are also 3 available pairs using the long sleeve and her 3 skirts. For her sleeveless, she can also pair it with the black skirt, the pink skirt, and the black skirt. So there are also 3 available pairs she can choose from. So using the tree diagram, there are 12 pairs in all. So therefore, Anna has 12 ways to select her outfit. For solving the same problem using fundamental counting rule, so we have here 4 different blouses and 3 different skirts. You will just simply multiply the number of blouses times the number of skirts. So that is 4 times 3 is equal to 12. So therefore, Anna has 12 ways to select her outfit. For example number 2, suppose you secured your bike using a combination lock. Later, you realize that you forgot the 4-digit code. You only remember that the code contains the digits 1, 3, 4, and 7. How many possible codes are there if repetition is not allowed? Solve the problem using listing method and fundamental counting rules. So this is an example of a combination lock. Now, how many possible 4-digit codes are there using 1, 3, 4, 7 if repetition is not allowed? When we say repetition is not allowed, in every code, there will be no digit that are alike or the same. These are all the possible 4-digit codes using the digits 1, 3, 4, and 7 using the listing method. When we say listing method, you are going to write or list all possible 4-digit code using the given digits. As you can see in these codes or in this example, since repetition is not allowed in every code, there are no digits that are repeated or alike. There are 24 possible codes. In this example, the order or arrangement of numbers does matter. In other words, you cannot open the lock if you use number with different order as to what is its unlock code. Now, how are we going to solve the same problem using the fundamental counting rule? So, how many possible 4-digit codes are there using the digits 1, 3, 4, 7? So, your blank here is for the 4-digit code. So, since repetition is not allowed, for the first digit, you have 4 choices. So, you can choose from 1, 3, 4, 7. So, you have here 4. For the second digit, since repetition is not allowed, pag may napili na ditong first digit, so ibig sabihin, meron ka na lang na 3 choices kasi nga hindi pwedeng ulitin yung first digit. So, you only have 3 choices. For the next digit, since nagamit na yung 2 digit sa unahan, so hindi na pwedeng gamitin, so you only have here 2 choices. So that is times 2. For the last digit, since nagamit na yung 3, isa na lang ang pwede mong i-select. So you have here 1. So that is 4 times 3 times 2 times 1. And that is equal to 24. We have the same answer using the listing method and the fundamental counting rule. There are 24 possible codes in all.
For today's video lesson, our objectives are illustrate the permutations of objects, differentiate the kinds of permutations. We have the linear permutation, distinguishable permutation, and the circular permutation. And lastly, solve the different kind of permutations. Let us define permutations. Permutations refers to the different possible arrangement of a set of objects, and the order is important. Now, what does it mean? For us to understand the definition of permutations, let us have a very simple example.
What are the different permutations of the letters A, B, C? So we have here A, B, C, B, C, A, C, A, B, A, C, B, B, A, C, and C, B, A. Now, what have you observed in the given example or in the permutation of the letters A, B, C? Ano ang nariparo nindo sa tinaong halimbawa? Binaralanggado, baralanggado, nagsaralitan ki pwesto. So that is what we meant by permutation. The order or the arrangement of an object does matter. So meaning, in the previous example, ABC is different from CBA or ACB or etc. We have here the formula in finding the permutation of n objects taken at a time. You can write the notation of permutation in this form. We have here NPR, or you can use this symbol P, NR, where NR is enclosed in a parenthesis. This is equal to n factorial over n minus r factorial. And n is greater than or equal to r. And the permutation of n objects taken all at a time is equal to n factorial, where n in the formula is the total number of objects and r is the number of objects used in every arrangement. The permutation of n objects taken r at a time is denoted by P and R. In some books, it is also denoted by these symbols. So if you see these symbols, this means permutation.
During your science subject, you have learned that gardening is the practice of growing and cultivating plants as part of horticulture. During quarantine, many of us became hooked in this activity. We became familiar with the words or term plantita, which is originated from the words plant and tita or the auntie, and plantito, which is originated from plant and tito or uncle. It is a new social media jargon used to describe people who find joy and fulfillment in planting and gardening.
Suppose we have 6 different potted succulent plants and we wish to arrange 4 of them in a row. In how many ways can this be done? So we have here 6 different potted succulent plants and you are going to arrange 4 of them in a row. So you can choose 4 plants from these 6 succulent plants to arrange in a row. So how many ways can this be done? So you can arrange it this way or this way, and so on and so forth. Now, how are you going to compute the number of ways this can be done? To solve this problem, you are going to determine first the value of n and the value of r. For the value of n, this is equal to 6 since the total number of succulent plants is 6. And r is equal to 4 since the total number of plants that you are going to use in every arrangement is 4. Now, substitute the value of n and the value of r to the given formula. We read this as permutation of 6 taken 4 at a time. You can also use the other symbol for permutation such as P or 6P4. You can also use the symbol like this one. They are all the same and we read this as permutation of 6 taken 4 at a time. This is equal to 6 factorial over 6 minus 4 factorial. So 6 minus 4 factorial is equal to 2 factorial. Now, how to simplify 6 factorial? This is just equal to, you will start from 6, multiply it to 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. To simplify, this is equal to 360. Therefore, there are 360 ways to arrange the plants.
You can also solve the given problem using a calculator. This is how you are going to input 6 permutation 4 in your scientific calculator. In most gambling games, it is customary to express the idea of probability in terms of odds against winning. This is simply the ratio of the unfavorable possibilities to the favorable ones. To predict the odds of winning, one must know how to quantify all possible outcomes or possibilities.
Suppose 8 runners join a race. In how many possible ways can they be arranged as first, second, and third placers? I'm giving you 3 minutes to answer this problem. Now let us try to solve the problem. You have to identify first the value of n and the value of r. So in this problem, the value of n is equal to 8 since this is the total number of runners who joined a race. The value of R is 3 since there are 3 ranks, that is the first, the second, and the third. Now let us substitute this to the formula of the permutation, which is permutation or n permutation r is equal to n factorial over n minus r factorial. So this is, by substitution, 8 permutation 3 is equal to 8 factorial over 8 minus 3 factorial. 8 minus 3 is equal to 5, so 8 factorial over 5 factorial. Now, let us simplify 8 factorial and 5 factorial. That is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial. That is 5 times 4 times 3 times 2 times 1. So, by multiplying all the digits in the numerator, that is 40,320 over 120. Or, this is equal to 336. We just divide the numerator by the denominator.
Therefore, there are 336 ways to arrange the runners.
Now, you can solve this problem this way. So, this is 8 factorial over 5 factorial. Method number 2. So, let us say this is your method number 1. So, we have here 8 factorial over 5 factorial. So, you can write 8 times 7 times 6 times 5 factorial. Since 5 factorial, this is 5 times 4 times 3 times 2 times 1. So, hanggang 5 factorial lang siya kasi yung denominator natin is also 5 factorial para mas madali ang pagsulat and mas madali ang pag-solve. And we can now cancel 5 factorial from the numerator and the denominator. So, ang natira na lang dito is 8 times 7 times 6. And if you are going to multiply 8 times 6 or times 7 times 6, that is equal to 336. We have the same answer. For method number 3, you can also use your calculator.
To solve using calculator, you will just simply input 8 permutations. You will first click shift and find for NPR. So that is in the times 3. So that is 8 permutation 3. Click equals. That is 336. Thumbs up for those who got the correct answer. For those who did not get the correct answer, it's okay. There are still more problems coming next.
Let us now proceed to the second kind of permutation. We have here the distinguishable permutation. It refers to the permutations of a set of objects where some of them are alike. The number of distinguishable permutations P of an object where P objects are alike, Q objects are alike, R objects are alike, and so on is given by P, or the permutation of object, is equal to n factorial over P factorial times Q factorial times R factorial, and so on and so forth. Again, n here is the total number of objects. Now, let us try this example. Find the number of permutations of the letters of the word is statistics. So, this is an example of distinguishable permutation since, as you can see, from the letters of the word statistics, there are letters that are being repeated. So, we have here S. So, we have 3S. We have 3T and 2I or 2 I's. So, tatlong beses na ulit si S, Tatlong beses na ulit si T, dalawang beses na ulit si I. Now, to solve for distinguishable permutation, we have the formula permutation is equal to n factorial over p factorial times q factorial times r factorial, and so on and so forth, where n here is the total number of the letters of the word statistics. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have here 10 letters. So that is 10 factorial over p factorial, q factorial, r factorial. P, Q, R here are the letters that are being repeated. So we have here 3s, so that is 3 factorial. 3 t's, that is 3 factorial. 2 i's, that is 2 factorial. Now, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We have here 3 factorial times 3 factorial times 2 factorial. Now, para mas bumaba ang number or hindi masyadong mahaba, mag-cancel out tayo from the numerator and the denominator. So, this 3 factorial, this is just 3 times 2 times 1. So, pwede natin yang i-cancel. Ang 3 factorial is 3 times 2 times 1 or that is equivalent to 6. So, we can cancel 3 factorial and yung 6. 2 factorial is equal to 2. Pwede natin itong i-cancel tsaka sa 4 and yung 4 mo magiging 2. So, ang matitira sa numerator, 10 times 9 times 8 times 7 times 5 times 2. So, by simplifying, by multiplying all the numbers, that is 10 times 9 times 8 times 7 times 5 times 2, this is equal to 50,400. So, therefore, there are 50,400 permutations of the letter of the word is statistics. Now, for method number 2, say for example, this is method number 1. For method number 2, which is the easiest way, is you can solve this using the calculator. Let us try another example. Find the number of permutations of the digits of the number 83,738. Use the formula to solve the problem. So this is an example of distinguishable permutations since there are digits that are being repeated or there are digits that are alike. So I'm giving you 3 minutes to answer this problem. Okay, let us solve the given problem. So we have 83,738. We have here the digit 8. Twice siya naulit. We have here the digit 3. Twice din siya naulit. So this will be the value of P, and this will be the value of the Q. And the value of N is the total number of digits. This is 1, 2, 3, 4, 5. So by substitution, P is equal to N factorial. By the formula, N factorial over P factorial, Q factorial, R factorial, and so on and so forth. P is equal to N is 5, so this will become 5 factorial. The digits that are being repeated is 8, twice siya na ulit, so 2 factorial. The 3, twice siya na ulit, so 2 factorial. So this is equal to, so 5 factorial is 5 times 4 times 3 times 2 times 1 over 2 factorial times 2 factorial. 2 factorial, this is 2 times 1. 2 factorial is just equal to 2. So, pwede nating i-cancel sa 4. So, matitira, 5 times 2 times 3. 5 times 2 times 3, this is equal to 30. So, therefore, there are 30 permutations of the digits from the number 83,738. Suppose this is your method number 1. For your method number 2, you can use your calculator. Again, thumbs up for those who get the same answer, and for those who do not get the same answer, you can try again later, and surely you will get the correct answer. Now let us proceed to circular permutation. It refers to the different possible arrangement of objects in a circle, or you are arranging the object in circular manner. The number of permutations P of n objects around a circle is given by P is equal to n minus 1 factorial, where P is the permutation of objects and n is the total number of objects. Let us try this example. Due to the increasing number of COVID-19 active cases in Legazpi City, Mayor Noel Rosal called for a press conference for safety reminders and announcements to all Legazpeño. This was attended by 8 media men from different TV and radio stations such as GMA, DZGB, Bombo Radio, DWZR, DWRL, Sagitsit, Idol FM, and Sigaw News FM. Following the IATF protocol, these media men were not allowed to go closer to the mayor, and they are seated a meter apart from each other in a big round table. In how many ways can these 8 people be seated around a circular table? So in this example, you are going to arrange these 8 people in a circular manner. So this is an example of circular permutation. So for circular permutation, we have P is equal to n minus 1. And here is the number of people that you are going to arrange. So P is equal to 8 minus 1 factorial. And 8 minus 1 is equal to 7. So P is equal to 7 factorial. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. So multiplying all the digits, this is equal to 5,040. So therefore, there are 5,040 ways to arrange these 8 people around a circular table. That is for this example. For example number 2, find the number of different ways that a family of 6 can be seated around a circular table with 6 chairs. So this example is still an example of circular permutation since you are going to arrange 6 people in a circular table. So I'm giving you 3 minutes to answer this problem. To solve this problem, you have to identify or determine the value of n. So n here is equal to 6 since there are 6 members in the family. Or you are going to arrange 6 people in a circular table. So by substitution, p is equal to 6 minus 1 factorial. And 6 minus 1 is equal to 5. So this is 5 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. So 5 factorial is equal to 120. Therefore, there are 120 ways to arrange the family of 6 in a circular table. If you get the same answer, very good, and thumbs up for those who have the same answer. For those who did not get the correct answer, you may try later. There are 4 different mathematics books and 5 different science books. In how many ways can books be arranged on a shelf if books of the same subject must be placed together? So meaning, lahat ng math magkakasama, lahat ng science books magkakasama din or magkakatabi. You can arrange the books in this manner such that the math books are on the left side of the shelf and the science books are on the right side of the shelf. You can also arrange this in this manner such that the science books are on the left side and the math book the math books are on the right side of the shelf. So, since pwede natin i-rearrange yung dalawang subject, so for the 2 subjects, we have here 2 factorial. Another arrangement is that itong science books, science 7, 8, 9, 10, 11, pwede nating i-rearrange. Say for example, andito si science 8, followed by science 9, 11, 10, and 7. Or, pwede mo pa siyang i-rearrange in different ways. So, since there are 5 science books, you can arrange these science books 5 factorial. The same with math books, you can arrange this 4 factorial ways. So all in all, you can arrange the science in the math books such that same subjects dapat magkakatabi. So the total permutation, you will just simply multiply this 2 factorial times 5 factorial times 4 factorial. Itong mga possible arrangement. So, the permutation is equal to, this is 2 times 1, 5 factorial is 5, times 4, times 3, times 2, times 1, times 4 factorial is 4, times 3, times 2, times 1. So, multiplying all the numbers, 2 factorial times 5 factorial times 4 factorial, this is equal to 5,760. So, therefore, there are 5,760 ways to arrange the books. With the condition na dapat daw lahat ng magkakaparehong subjects ay magkakatabi. To sum up our discussion for today, let us define again the 3 types of permutation. So we have here the permutations refers to the different possible arrangement of a set of objects. The order is important. For distinguishable permutation, it refers to the permutations of a set of objects where some of them are alike. The number of distinguishable permutations P of an object where P objects are alike, Q objects are alike, R objects are alike, and so on is given by this formula. For circular permutation, it refers to the different possible arrangements of objects in a circle. The number of permutations P of n objects around a circle is given by this formula.
Are you familiar with the combination lock? It is a type of locking device in which a sequence of symbols, usually numbers, is used to open the lock. So say for example, if the passcode or the digits that used to unlock the key is 1, 2, 3, 4, you cannot open the lock with the key 1, 2, 4, 3. Now, if you are going to analyze carefully, it is supposed to be a permutation lock because the arrangement of the digits is important.
For your evaluation, you are going to answer the following problems. So for practice task 1, you are going to solve the problems below by filling up the missing parts of the solution. So 1 point each blank. You can take screenshots for practice task 1 and you can submit your answer on the next retrieval of your modules and answer sheets. For practice task 2, this is solving word problems. We have here 3 problems and each item is 5 points. For practice task 3, this is also a word problem. So this is the rubric for practice task 2 and 3. So for every item, you will get 5 points if you got the correct answer with complete solutions. You will get 3 points if you got the correct answer but you have an incomplete solutions. And 1 point if you try to answer the problem but you got the incorrect answer. And of course, 0 point for those who did not try to solve any of the problem. So that will be all today about permutations. I hope you learned something. Thank you for watching and listening to our discussion for today. Have a good day.